Welcome everyone today on this session, Operations Data Lake for Capacity Planning and Analytics by using Oracle Cloud Infrastructure Operations Insights. This is Sriram Vrunda, Product Manager at Oracle for the Oracle Cloud Infrastructure Operations Insights service. We will talk about how using Operations Data Lake, you can leverage the Operations Insights service for solving your various IT operations use cases. Here is the safe harbor statement. Let me pause it for a moment for you to go through. Let us go ahead and look at the agenda now. We will touch upon the challenges that customers are having today to address the IT complexity and high performance demands of the enterprises, followed by an overview of the Operations Insights service and discuss about the solution areas in this context to help efficient use of infrastructure resources, plan for future, and also improve the application response time, all in the context of Operations Data Lake. And in the end, we will leave some resources so that you can take next steps with Operations Insights. Let's look at the customer challenges. Some of the common requirements for IT operations is to get answers for questions like, do I have adequate compute, storage resources to accommodate forecasted growth in CPU or storage usage? Can I get an inventory view of resource usage across deployments? Which databases are the biggest consumers of resources? How can I prioritize my operational tasks more effectively and efficiently by embracing machine learning related technologies? And more importantly, how do I enable custom analytics on operational data using a data lake? So the key use cases that we try to solve using the operational data that is vast in nature is capacity planning, automated response and remediation. How do I do continuous performance analysis and make use of technologies like AutoML or machine learning? And this has to be performed at cloud scale. We have data spread across multiple systems within the database, within Oracle engineered systems, within Linux hosts, or any other monitoring solution like Enterprise Manager. If you have been using them to manage them, you'll have the data there as well. Now, in this session, we look at how Operations Insights in the Oracle Cloud Infrastructure service can solve these problems for you. And that's where we introduce Operations Insights, which is the IT analytics reimagined for OCI Gen2 Cloud. Oracle Cloud Infrastructure Operations Insights is an OCI native service that provides 360-degree insight into database and host resource utilization and also capacity-related requirements. Operations Insights expands on the IT operations to provide insights across data center assets, embrace machine learning-based and data-driven capacity planning, and perform proactive performance management, wherein it ingests data from different systems in the IT enterprise, thereby creating an operational data lake, processing real-time data as well as historical data through this operational data lake. And finally, how do we amalgamate data lake and AI ops? Operations Insights with your IT infrastructure, be it on-premises or on cloud, will allow you to ingest monitoring and SQL data from varied set of databases and host resources for enhanced observability. You can build data lakes to consolidate and secure data from different sources and formats into a single repository for easy access and analysis. With the data lake approach, we now can collect a variety of data from a variety of sources with huge volume and velocity. Operations Insights applies machine learning to correlate and transform that data so that you can take actionable incidents and even perform custom analytics on these data. Now let's look at the key value propositions that Operations Insights has to offer. It allows you to do simple stuff at scale on curated data and makes harder stuff possible, thereby making it possible for enterprises to automate and enhance their business services. You could anticipate and control capital expenditure using aggregated demand forecasts using the service, and also improve application throughput by tracking and trending SQL execution performance across the enterprise. Now let's look at the solution areas that allows you to do effective capacity planning, effective SQL performance tuning. In order to do capacity planning for databases and hosts, you can use the capacity planning app, which allows you to trend and forecast resource requirements. SQL Warehouse is an application within the Operations Insights service which allows you to get insights into the SQL performance. Now, if you have Exadata systems in your data center, be it on-premises or in the cloud, you can get deep insights into the resources and also how effectively can we do database consolidation by looking at the various Exadata metrics. As we started with the discussion of data lake, we have a variety of data that comes into the Operations Insights. You can have AWR data, and you can create a hub out of it called as the AWR hub. You can ingest all the enterprise manager data into Operations Insights, thereby creating a warehouse of the enterprise manager, which is called as the EM warehouse. You can also ingest a variety of data pertaining to your Exadata infrastructure, host metrics, storage metrics, and also the database related metrics so that you could do a warehouse for your Exadata from an analytics or from an operations standpoint. And this data lake scenario can also be used for custom analytics, wherein you can make use of your own queries, make use of your own custom built apps to provide any kind of custom analytics. Now let's look at some of the out-of-the-box apps that are provided by Operations Insights. But the technology for enabling these features or these applications would remain the same, wherein we use the operational data lake. Operations Insights would ingest data from various sources, be it database, host, or Exadata, and allows you to create or consume out-of-the-box provided dashboards or out-of-the-box provided applications. We look at them one by one. Let's look at the forecast resource requirements. As a database fleet administrator or capacity planner, the capacity planning application lets you perform the following use case goals at the compartment level for both CPU and storage resources. You can obtain a bird's eye view of aggregate database CPU allocation, utilization, and usage trends. You can view fleet-wide distribution of allocated database CPU resources and their utilization levels, thereby gaining proactive insights into current CPU or storage utilization issues or forecast to near term. You can identify relocation opportunities, estimate the cloud migration footprint, and also configure auto scaling for autonomous database based on this analysis or this trend. So thereby you could actually go and aggregate the demand at a compartment level where you have a fleet of databases deployed within that particular compartment. You also can predict demand from changing workloads, which allows you to understand more about questions like, do I have adequate compute storage resources to accommodate forecasted growth in CPU or storage usage? Trend and forecast aggregate CPU utilization for all or specific groups of databases. Trend and forecast aggregate storage utilization for all or specific group of databases. Trend and forecast CPU utilization for specific databases of interest. Estimate the opportunity cost of resource allocation for highly variable CPU demand. You can quickly identify candidates for Oracle Autonomous Database auto scaling, which we discussed earlier. So wherein you can quickly isolate the largest, most utilized, and fastest growing databases. And it also relies on inbuilt machine learning, creating its own seasonality models and gives you automatic prediction of near-term issues. The trend and forecast demand is using up to the 25-month historical data that gets embedded or that gets ingested into the Operations Insights warehouse by using the Operations Data Lake technology. Now, from a visualization perspective, you could do tree map visualization of the entire fleet, tree map of CPU, storage and memory utilization over all databases in the compartment. And then you can also do a time series chart of CPU usage trends and forecasts for individual or group of databases, thereby isolating databases with current or forecasted high or low utilization. You can quickly compare these databases to each other by size or usage to prioritize analysis. You can identify databases with fastest growth or shrinkage in CPU demand over the time period. And this is actually allowing you to quantify underutilized footprint for repurposing or to do consolidation exercises or maybe to allocate resources in an appropriate fashion. Once we are done with the capacity planning exercise, we also need to deal with our day-to-day use cases in terms of how do I make sure that my application that is critical in nature for my business is performing well. How do I take remedial actions immediately so that there should not be a problem for my business critical application? Using the Oracle SQL warehouse function of Operations Insights, you can analyze the SQL performance problem for enterprise-wide applications across a fleet of databases. In addition, Operations Insights provides trends and key insights into SQL performance issues, thereby helping you to be proactive in avoiding future problems. You can analyze the performance of SQL based on categories like degrading SQL, inefficient SQL, variation or a variant SQL, and with plan changes. Thereby, identify top SQLs based on DB time across databases. So this allows you to have questions like, is there a performance problem that is happening? Is it kind of stable or is it worsening? And also identify top SQLs based on various dimensions. You can also do historical execution profiling, wherein the performance of a SQL over time can be broken down by DB time or average latency. You can do response analytics by execution plan or by a latency bucket. You can view the number of plans per SQL and get further insights into SQL performance based on details such as the best performing plan, most executed plan, and plan with the most I/O. This also allows you to take remedial actions, wherein if you see suddenly a problem with a particular SQL changing a plan, you would be able to sort to remedial measures and get alerted on what is the current plan and why did it change, etc. Now, if you are using Exadata for your database requirements, you can use Operations Insights to forecast resource requirements for Exadata systems as well. You can do enterprise-wide analysis of resource utilization capacity planning for Exadata systems, improve resource utilization by identifying under and overutilized resources. You can also identify the lead time to expand capacity. This is based on the machine learning based forecast and also on the long-term historical data that is there within the Operations Insights warehouse by using the operational data lake that gets created. We'll talk about the data lake and how do we make use of data lake and what is the architecture in our subsequent discussion. This feature is currently going to be available and will be available in the second half of 2021. Exadata Insights also allows you to consolidate Oracle databases on Exadata, wherein you can identify Exadata servers that would satisfy resource requirements, find low resource utilization servers. By using the forecasting and the capacity planner functionality, you can ensure that the Exadata satisfies future needs of databases that are being consolidated, estimate usage for 12 months, thereby allowing you to plan ahead using performance history and seasonality. And this also ensures you that your IT operations service levels are met over time. Now let's look into the discussions about data lake for custom analytics. So far, we have been discussing about the out-of-the-box provided apps within the Operations Insights service, but the foundation to all this is a data lake. We can use this data lake for custom analytics as well. So at this point, I'm going to introduce what a data lake is, which is the foundation for getting all the data in the context of Operations Insight service, the IT operations data in the context of Operations Insight service. But essentially, what is a data lake, which is kind of a broader phenomenon? Data lake is a place to store your structured and unstructured data, as well as a method for organizing large volumes of highly diverse data from diverse sources. So the definition can be found out within the oracle.com website that we have provided here. But then let's understand this further. The data today, be it an operational data or a business data, is divided into structured and semi-structured or even unstructured data. Accommodating all these different data into one single warehouse would define the data lake. Now, just like a lake, you have multiple streams coming in. A data lake has structured data, unstructured data, machine to machine, and also logs moving through in real time. Now with cloud native data warehouses like Oracle's autonomous data warehouse, more cost-effective alternatives available to store huge amounts of readily available data. Also, a newer concept is having a data lakehouse architecture where the underlying storage behaves like tables in a relational database when it comes to querying and writing data into the data lake. Data lakehouse is a further evolution of data lakes. The storing and processing of historical data from different sources to derive value for your business has been and will be an ever-evolving process. Now, in this context, Operations Insights makes use of Oracle's autonomous data warehouse database as its backend, and it gets various data ingested into this warehouse by using technologies like Oracle Object Storage and also its own inbuilt extract, load, and transform technologies. And that's where we need to understand why do we need to use data lake in the context of IT operations to enable IT operations function better. If you look at the current scenario that you might have data for IT operations which are pertaining to databases, which are pertaining to engineered systems, which are pertaining to your Linux hosts, wherein your compute for the databases would rely. And that's the key attraction here. Now, this data can be residing within a traditional data center, which is on premises. It could also reside in an Exadata clouded customer machine, and also might be residing in a public cloud service. Some of these targets could be managed by using Enterprise Manager. Some of these targets might be using some other monitoring solutions or the OCI monitoring solution or the OCI Observability and Management platform-based solutions. Now, when you look at this, you would see that there is a siloed operational data in the form of AWR Workload Repository or the AWR, which contains a wealth of information about the Oracle performance statistics. Now, for Exadata, you have a lot of Exadata storage metrics, which allows you to do capacity planning, which allows you to understand more about I/O distribution across multiple databases, top DB consumers, I/O reasons, and also understand more about the fault diagnostics within the Exadata storage engine itself. And if you're managing these systems using Enterprise Manager, Enterprise Manager also has a variety of informations like configuration related data, configuration changes over a period of time, the historical data with respect to the database metrics, database configuration, and related logging data, etc. Now, the problem with that approach is that you have a siloed operational data but we need to break down this data silos to gain full visibility across the enterprise fleet. Now, this is where the data lake comes into picture, which provides deeper insights into operational data, wherein you can use data lake for longer term storage. You can also make use of this data to provide enterprise-wide view of resource usage and allocation. And most importantly, if you want to use your own analytics tools, or if you want to leverage your own skills from an analytics perspective, you can all solve specific use cases or specific issues like noisy neighbor issues on Exadata, and any use case that is not satisfied by the out-of-box apps provided by Operations Insights service. Now let's look at the data lake from an Operations Insights perspective. Operations Insights allows you to create Enterprise Manager data lake, wherein by making use of this data lake, you can search and browse system data and correlate that with the business metrics. You would see that on the left-hand side, there could be Enterprise Manager data, which could be coming from multiple enterprise managers that would monitor disparate systems. You could also have data coming in from systems that are not monitored by Enterprise Manager. But if you're using Enterprise Manager, and if you want to actually ingest all the data into Operations Insights by using the Operations Data Lake, you can create something called as a cloud bridge, wherein it allows you to connect Enterprise Manager with Oracle Cloud Infrastructure and thereby harvesting metric, SQL, and configuration data for deep operational analytics, which provides visibility and analytics across multiple Enterprise Manager sites. Now, on the right-hand side, you would see an Oracle Autonomous Database, which is the warehouse wherein all this data gets ingested into by using the Oracle Cloud Infrastructure Object Storage as the intermediate technology. And all the data that gets ingested into the OCI Object Storage gets loaded onto the Operations Insights, or you have an extract load transformation that happens. And thereby, once you have this data, you can perform analysis, you can do trending and forecasting on longer term data. And also based on this, you could extend this capability to make use of other OCI observability and management solutions like logging analytics, make use of the Oracle Analytics Cloud Data Science, or even open source Jupyter notebooks or Apex applications to build your own custom analytics based solutions. Now, this is how the architecture would look like. You have Enterprise Manager deployed in your data center. It could be also on Oracle Cloud Infrastructure. If you don't have Enterprise Manager, you can still send your data into Operations Insights by making use of an agent-based technology. But in this case, we are concentrating on Enterprise Manager Data Lake. This requires a minimum of Enterprise Manager 13.5. You can create a cloud bridge at both sides so that EM understands that it has to send data to Operations Insights, and Operations Insights understands that it has to talk to an OCI object storage to get the data ingested into its own warehouse. Cloud Bridge is an OCI landing zone for off OCI data. It lives in the customer tenancy, which is there positioned as an object storage location. It supports structured and unstructured data, which is highly scalable and secure as it uses Oracle Cloud Infrastructure native technologies. Now, Operations Insights is built on a warehouse which is based on Oracle Autonomous Data Warehouse. It supports data from various sources. It could be an AWR hub, which contains AWR data from multiple databases. So this AWR data can be ingested into Operations Insights via Enterprise Manager or maybe as a standalone replication that you would want to perform to OCI object storage and get an automated ETL onto the AWR hub. You can also send your enterprise manager data, building an enterprise manager warehouse or an Exadata warehouse. All these capabilities would be soon available in this calendar year, and enterprise manager warehouse will be made available in the next calendar year, which is the calendar year 2022. The key features would be automated ETL, and also you have a rich platform for service with out-of-the-box UX, and also provides you the capability to have a custom analytics on top of this data. Beyond that, you could also extend this technology to make use of other OCI observability and management solutions like logging analytics, and also make use of Oracle Analytics Cloud Data Science or the Jupyter Notebooks for performing any kind of custom analytics or custom analysis. Now, to wrap up today's session, Operations Insights is an OCI native service that provides 360-degree insights into database and host resource utilization and capacity. The service analyzes large volumes of IT data stored in a warehouse platform to provide out-of-the-box and user-defined custom analytics applications, thereby allowing you to optimize your operations and plan capital expenditure better. By applying machine learning, you can train the tool in such a way that it will help you identify anomalies so that your application can run smoothly and avoid high severity outages, and you don't have to be a data scientist to use it. Customers have different monitoring and management needs, and Oracle differentiates itself by providing customers a choice of services and solution. And when customers make a choice, it is not yet another tool or different source of truth. It is part of an integrated platform with scale, extensibility, and includes years of management experience and latest technology. And that's where you have a plethora of observability and management solutions that complement each other, wherein you have database management service, operations insights, logging analytics, and application performance monitoring. We have many customers, partners, and analysts that have validated this technology. You can certainly explore those at your leisure, but more importantly, if you want to get started, here are some of the useful resources we encourage you to go through, and you can use this information here for you to learn yourself how the OCI Operations Insights can help you in your business today. Thank you to all those attending today.